So the plot thickens. We have even more new evidence that suggests chronic pain and fatigue may have something to do with poor oxygen supply in the brain. And I want to tell you what we found. I'm Dr. Younger. I'm director of the Neuroinflammation Pain and Fatigue Laboratory. And this is the channel where I present scientific findings basically as soon as I make them, and in the hopes that the information will be helpful for those who are struggling with chronic pain, fatigue, and related disorders. So last week, I showed that poor oxygen perfusion in the brain may cause chronic pain, fatigue, and cognitive problems. And I was looking specifically at a group of individuals with Gulf War illness. Now, by the way, I mentioned in that video that I would also look at this in fibromyalgia and chronic fatigue syndrome. And all of those data have been processed by the computer, but I did not have enough time to go through and interpret the results in time for this video. So it will be next week when I present the chronic fatigue syndrome and fibromyalgia data. So let me tell you what I was doing over the past week in the Gulf War illness group. So in the past week, we looked at other scans to see if they contribute to this story of poor oxygen perfusion in the brain. And that's part of what we do as scientists. We fit little puzzle pieces together. We take little scraps of information and evidence, and we see if they fit together to form a coherent picture. And when a coherent picture emerges, that can tell me what treatments to prioritize for testing. So let me tell you what we found and why it's really interesting. So again, here's the starting point, and I'll link to the previous week's video if you haven't seen it yet. But where we're starting from is we have this scan that shows us that there's poor oxygen perfusion in the brain of people with these chronic disorders. So we started to look at other brain metabolites using a different scan to see if we could figure out more of what's going on in the brain. And one noticeable thing that I've looked at in the past week was increased lactate in the brain of these people with the chronic disease who also have the fatigue and pain and cognitive disruption. So we see large areas of the brain with increased lactate. And I'm going to show you a little image here so you can see what I'm talking about. And really all the areas that are in green have abnormally increased lactate. So we're talking about the frontal lobe, which is a very large region of your brain, the occipital lobe, and a lot of the limbic system. So basically what you see in green. So really it's much of the brain. It may even be most of the brain. In any case, it is a significant portion of the brain in this chronic pain fatigue group has increased lactate. Now, lactate is a sign of poor oxygen availability in the brain. And the short story is, basically every cellular process, really every process in our body is driven by mitochondria. And the mitochondria are the engines for everything. Now, the mitochondria need fuel to do their thing, and that's adenosine triphosphate, or ATP. Now, to get ATP, it comes from glucose, but it has to have oxygen to be converted into ATP. So the fuel for basically every fundamental process in our body comes from glucose that's been converted to ATP involving oxygen. Oxygen is a critical part of that process. And I'm leaving out the steps. You can find that elsewhere. So I'm only giving you the first and the end. That's all that's important for right now. So you have to have oxygen to get energy for the mitochondria. If you don't have it, your whole system falls apart. You can't live. Nothing will work. Now, because it's so important to have the mitochondria working, there actually is a backup system that doesn't require oxygen. And in that process, the glucose, instead of turning to ATP, turns into lactate. And again, this is a backup process. It's not the optimal way to get energy for the mitochondria, but it can work in a pinch, like in urgent situations. So again, two pathways. One leads to ATP, that's the primary, but the secondary backup process leads to lactate. So when we see a lot of lactate in the brain, that's suggesting to us that something has happened with the primary ATP pathway. And so now the system has directed over to the anaerobic system, which doesn't require oxygen, lactate process. And this can easily explain the fatigue issues and the cognitive problems that someone is that's having. So we see all this lactate in the brain, which again is suggesting the primary energy system is not working, probably because of a lack of oxygen. And so then we looked at lactate in the body, and you can do that with just a blood draw, just a venipuncture. And we found that in this group, there was a lot of lactate in the body as well, and it was quite significant. It was like 0.0017. So there was quite a bit more lactate in the chronic condition group versus the controls, which were veterans who didn't have Gulf War illness. So now we've got evidence of poor oxygen in the brain and in the body. Now the question is why? Why is there a lot of oxygen? Why is there problems with oxygen perfusion? So we looked at other metabolites, and the one that really jumped out as having widespread abnormalities in the brain was choline. And in the GWI group, there was decreased choline throughout the brain, and we can measure that with magnetic resonance spectroscopy. Now, choline is a precursor for acetylcholine, and these are extremely important elements in the body. Now, both choline and acetylcholine are responsible for, among other things, responsible for vasodilation. And vasodilation is when your vessels grow larger, and so they allow more blood to run through, and it increases the oxygen that is available to all the tissues of your body and all the cells of your body. And this is especially important in those little small capillaries and the small vessels in your brain as well. So if you don't have enough choline throughout your system, your vessels will not be as pliable and they will vasoconstrict, and there will not be enough oxygen served to your body and to your brain. That will cause fatigue and cognitive problems and some other symptoms as well. So if we put all this together, let me give you this little image. What we're seeing from this one study is we're seeing reduced choline leading to kind of poor vascular health. And by the way, I did not assess vascular health directly in the study. It was not the intention of the study. So this is just using other literature. This is the one piece that I did not measure directly. All the other pieces I looked at directly. But low choline leading to poor vascular health, which then leads to poor cerebral perfusion, which we observed, which then leads to the kind of excess lactate that we're seeing, and that would also lead to fatigue and cognitive issues. Now, why is the choline decreased? I put this little question mark at the top. I do have explanations and hypotheses as to why this would be the case, but I'm not going to talk about those right now. My graduate student, Chloe Jones, is running this as her dissertation, and she's exploring those questions. And so we'll have a lot more to say about that at a later time. What's mostly important right now is what do we do about it? There's a lot, dozens of possible approaches that could work given the things that we're seeing in the brain from the imaging. One possibility would be giving a choline supplement. If the choline is lower in the body and the brain, then it may just need to be boosted, and that might improve symptoms. Now, unfortunately, I did not test choline in the blood, and that's because I wasn't expecting there to be abnormalities with choline. Now that I know there's deficient choline in the brain, I need to go back to some old samples and get choline run to see if it's also true in the body before I start looking at choline. So choline is not at the top of my list of things to try. But anyway, that could help. There's hyperbaric oxygen. And so if you do a lot of those, it's pretty expensive and it takes a lot of treatments, a lot of sessions, but it can improve long-term oxygen perfusion. So the hyperbaric oxygen treatments might help. Reducing inflammation would be very important. So if you have systemic inflammation, that means those inflammatory messengers are going through your vessels and they attack your vessels as they go, and that reduces the elasticity of the vessels and causes them to constrict. So reducing inflammation would be very important. A diet that's rich in antioxidants would be very important. But of all the possibilities, the one I'm going to investigate first is the French maritime pine bark. And I talked about this a few weeks ago. I'll link to that video as well at the end of this one in case you missed that. But I'm really interested in the French maritime pine bark because it is anti-inflammatory, which I think will be helpful. It has the antioxidants that I think will be helpful. But what I really like is the literature showing that it improves oxygen in the body and in the brain. So it helps with that perfusion of oxygen. And there's a lot of good studies showing that that's the case. And there's very few things that can work in the body and get through the blood-brain barrier in amounts sufficient to actually affect oxygen perfusion in the brain. And this seems to be one of those rare compounds that can do that. So I really think the French maritime pine bark is the optimal way to address this problem that we're seeing with our imaging. So this is just a really quick update. I wanted to give you a little bit of the backstage view of my thinking process and how I decide what clinical trials to run, what treatments to go after, because if you've ever seen my list of compounds I'm interested in, it's in the hundreds now, and I have to have a way to prioritize them because there's no way I can run them all. And the way I do that is by doing imaging studies and blood tests and seeing, when I piece together all the results, is it telling me something that allows me to prioritize one treatment versus another? So that's all for this week. I need to get back to the analyses because we have a ton of data available now. So we have so much to present. There'll be a lot of exciting talks coming up as we get through the analyses and get some results ready for you. So I'm going to get back to it, and I will have more next week. So bye.